Hi everyone, have you ever wanted your system to automatically react whenever a file is uploaded or deleted in S3 without writing a single server or constantly checking for changes? That's exactly what event-driven architecture can do. In this demo, we'll show how an S3 bucket can trigger a Lambda function whenever a file is added or removed and how the results are logged in CloudWatch, all in near real time. Now let's visualize the flow in the diagram. In the diagram, on the left hand side, we have a user. The user interacts with S3. They can upload or delete a file. The user can be anywhere in the world, so they are not confined into the AWS region. Here, S3 acts as an event source inside the AWS region. Whenever a file is added or removed, it emits an event notification. Now moving to the arrow from S3 to Lambda, S3 itself does not execute code. Instead, it sends an event notification and AWS automatically invokes the Lambda function for us. Lambda receives event metadata about the file such as bucket name, object key, and event type. Importantly, Lambda does not automatically get the actual file. Instead, it receives metadata only. The Lambda function processes the event and writes execution logs to CloudWatch in near real time. This allows us to verify that the function ran successfully and see what event triggered it. On the right hand side, we have a CloudWatch logs service from AWS that receives logs from Lambda triggered by S3 events. Now let's move to the key points section, moving to the first bullet point which says same AWS region. What it means is that S3 and Lambda must be in the same AWS region so the event notification can trigger Lambda. CloudWatch logs are automatically created in the same region as Lambda. Moving to the second bullet point, event-driven architecture means a system reacts automatically when something happens instead of constantly checking or polling for changes. Final bullet point says near real-time execution. It means S3 triggers Lambda almost immediately and the execution log appears in CloudWatch within a few seconds. This is what we call near real time. Now that we know how the flow works, let's switch to the demo and see it in action. Now that we are in the AWS console, let's open Lambda. In this Lambda console, let's click Create a Function. Give this function a name. Let's choose runtime as Node.js. Scroll to the bottom and click Create Function. You can see our function called S3 event demo was created successfully. Scrolling down to the code section, let's delete this default code from index.mjs and paste a new code. Here we created a function called handler where we loop through each records from events, as S3 can send multiple records in one event. For each record, we are printing the bucket name, the key, and the event type itself. Now let's click deploy. We can see we have successfully deployed our new code. Now let's move back to our AWS console and open S3. From this S3 console, let's click Create Bucket. Let's give this bucket a globally unique name. Scroll to the bottom and click Create Bucket. We can see that we have successfully created a bucket called S3 Lambda Event Demo 1008. So let's select this newly created bucket by clicking it. Let's go to the Properties tab, scroll down, and under Event Notifications, let's click Create Event Notification. Let's give this event a name. For event types, let's select Object Creation and Object Removal for this demo. Scroll to the bottom, and for destination, we will be using Lambda function, so select Lambda function. Under this Lambda function drop-down, let's click and select our S3 event demo function. Now let's click Save Changes. Now we have successfully created our event notification called S3 upload delete trigger. Now let's scroll to the top and go to the Objects tab. Let's click Upload, click Add Files and select a file and click Open. Scroll to the bottom and click Upload. Now we see we have successfully uploaded a file. Now let's go back to our AWS console and open CloudWatch. In this CloudWatch console, let's open these logs from the left hand side menu. Under logs, let's select log management. Here we can see that Lambda has automatically created a log group called /AWS/Lambda/S3 event demo. So let's click this log group. Here under log streams, we see we have a single log stream. Let's click this log stream. Look at that. Upload event appeared in CloudWatch, confirming our Lambda function ran perfectly. We can see we have logged bucket name of S3 Lambda event demo 1008 with file key of mission possible.csv and event type of object created : put. Now let's move back to our S3 console. Let's click this close button. Let's check this checkbox and click delete. Let's confirm this delete and click delete objects. You see successfully deleted objects message. Now let's go back to our CloudWatch. Click AWS/Lambda/S3 demo. You can see we have another log stream. So let's click this newly created log stream. Again, we can see that delete event appeared in CloudWatch with the bucket name, with the key, and with the event type of object removed : delete. So these logs confirm that our Lambda function ran perfectly. And that wraps up our demo. As we saw, S3 event notification can automatically trigger Lambda function whenever a file is uploaded or deleted, and the execution logs are recorded in CloudWatch in near real time. This demonstrates the power of event-driven architecture. AWS reacts automatically to changes, eliminating the need for polling or manual intervention. You can extend this pattern to process files, send notifications, or automate workflows seamlessly. If you found this video helpful, don't forget to like, subscribe, and hit the bell icon to stay updated with more AWS tutorials. Thanks for watching.